Okay, so hi everyone. So my name is Suwei, and today I'm going to present predicting forest fires in Indonesia using remote sensing data. So this is a joint work with Kudip Miu as well as Massimo Lupascu. So let me just carry on the talk. So for the motivation of our project, the first thing we realized that is that for current fire forecasting system, they tend to use handcrafted features. For example, things like monthly or daily rainfall, and then so all these measurements and features, so-called features, require on-the-ground instruments. And also, they tend to use a lot of domain expert developed mathematical equations. So when you have such a system, it might have human biases when you're developing the system. So we're thinking, is there any alternative way of doing this, or is there any alternative approach to explore? And then we realized that there is a lot of remote sensing data available to the public. So instead, what we did was we tried to use this remote sensing data, and then we want to see if we could build a fire prediction system. And our motivation, and we chose Indonesia as basically the target location, because Indonesia has a history of forest fires, and they tend to be pretty serious. So for the data and prediction, the exact remote sensing data we used was from Landsat 7 satellite image data. And then we use this FIRMS hotspot data set. So FIRMS stands for, I think, Fire Information Resource Management System data set. So FIRMS data set actually is like an aggregated hotspot data set based on multiple satellite imageries. And we predict for hotspots 1 month into the future. So if we look at the timeline, the 1 year of historical satellite image data is actually the orange component. And then we're predicting for the green component, which is a 1-week window that is actually like 1 month away into the future. So we built a machine learning model, and the input would be a time series of satellite image histograms of a particular area. And we converted the satellite image into histogram representation due to storage constraints, actually. And for our prediction, we predict the prediction will be basically the confidence of forest fires happening in that particular area for the 1 month into the future. So our architecture is based on the convolutional LSTM architecture. So for every time step, we perform convolution between the different histogram bands. Sorry, between different histogram bands. For example, red, green, blue. As well, there's also different infrared bands involved to capture the relationship between the values. And then for each time step, we sort of use an LSTM to capture the relationship, the temporal relationship. So because the data set was actually very skewed, so most of the time you still wouldn't have any forest fires or hotspot. We had to develop a custom loss function to sort of penalize the false negative cases more often than not, because if you have 99% of the data does not have fire, then if your classifier always sort of classifies it as no hotspots or no fire, then you would achieve 99% accuracy, but that isn't what we wanted. So therefore, we had to do various measures to sort of counteract the skew in the data set. So here I'm just going to show a quick view of the results that we're getting so far. So we have this area under the curve results. So on the rightmost column, we use 1 year of data, but then we also explored with different varying lengths of data. To see how the model performs. So in case we do not have that much data, or we are unable to computationally store that much data, then we would like to explore the performance as well. So as you can see, we seem to achieve reasonable performance. Yep. And then I'll just quickly move on. So the conclusion is that we prototype a model to predict forest fires in Indonesia, so a neural network machine learning model. And we are basically using remote sensing data. And the benefit of this is that instead of having instruments on the ground, you can basically have easily available remote sensing data. And our exploration shows that this approach might be feasible or might be complementary to existing approaches.